Hello everyone. In this video tutorial, we will talk about traversal entry. So there are mainly two ways to do this. First one is the BFS, breadth first search. That means we will start with our root node and then we will go 8, then 3, then 10, then 1, 6, 14 and so on. So actually we will cover up the horizontal level first and then we will go down. Then actually the second type is DFS, that means depth first search. So actually we will first go down and then we will actually cover up the horizontal level. So here we will actually start with our 8, then we will go to 3, then we will go to 1 and then again we will come to 3 and then we will come to the 6, then to 4 and then again we will come to 6 and then 7. So in this way depth first search comes. So in depth first search, we are actually completing or the vertical level first and then the horizontal level as compared to our breadth first search. And for both of these types, the time complexity is O of n as we are covering each and every node. But actually where we can use BFS or DFS and what is the difference between them? Let's see. So firstly, BFS stands for breadth first search. On the other hand, DFS stands for depth first search. BFS can be implemented using level order traversal. On the other hand, DFS can be implemented using pre-order, in-order and post-order. And what does it mean pre-order, in-order and post-order? That we will see later. And then in our third difference point, it is saying BFS uses choose to find the shortest path, while DFS uses stack to find the shortest path. BFS is better when target is closer to the source. So at that time, BFS can be used. But when our target is far from the source, then DFS is better. BFS is slower than DFS, while DFS is faster than BFS. Along with that, one more point can be added for the time complexity. But here for both the things, the time complexity is same. So it is not the difference, it is the similarity. The time complexity of BFS as well as of DFS is O of V plus IE, where V is the vertices and E is the edges. Once we understood the difference between BFS and DFS, we need to understand where to use BFS and where to use DFS. So let's see. So here, if we know the solution lies somewhere deep in the tree or far from the source vertex in the graph, then we will use DFS. But if we know the solution is not far from the source, that means it is a closer. So at that time, we will use BFS. In the second point, it is saying if our tree is broad, then we will use DFS as BFS will take too much memory. Similarly, if our tree is very deep, then we will actually choose BFS over DFS. So in this way, now we know where to use BFS or DFS. In our next video tutorial, we will talk about DFS in depth. So my friends, please follow my complete playlist about data structure and algorithms to have complete understanding about all these topics. And thank you very much for now. Let's meet in our next video tutorial.